Hi students, again I came back with one more video based on regression. In this video, I want to discuss you about the regression problem, that is find two regression lines and also find the coefficient of correlation to the data. Okay, so here it is the data belongs to both x and y, where the values of x and y are 2, 6, 4, 3, 2, 2, 8, 4, and the values of y are 7, 2, 1, 1, 2, 3, 2, 6. So based on these data of both x and y, we are going to find out two regression lines. Okay, so as you already know that there are two regression lines. The first one is of regression line of y on x, and the second one is regression line of x on y. So here is of regression line of y on x, where y minus y bar is equals to byx into x minus x bar. And for this type of data, for regression line of y on x, you have to find out x bar and y bar, and you have to find out byx. So x bar is nothing but summation x by n, and y bar is nothing but summation y by n, where byx is the r into sigma y by sigma x. Byx is the regression coefficient of y on x, and small n is nothing but number of pair of observations, which is nothing but both x and y. Here, the regression line of x on y, where x minus x bar is equals to bxy into y minus y bar. X bar is nothing but x summation x by n, and y bar is nothing but summation y by n. And bxy is the regression coefficient of x on y. Here, r into sigma x by sigma y. Okay, so here byx and bxy are the two regression coefficients of regression lines. One is of r into sigma y by sigma x, and the one is of r into sigma x by sigma y, where sigma x and sigma y are the standard deviation for the x and y. Okay, now for the given data of x and y, we are going to find out x square, y square, and xy. What is meant by x square? The value of x will be squared. 2 square, which is 4, 6 square, which is of nothing but 36, 4 square 16, 3 square 9. Like that you are going to find out still up to the last value of 4, that is of 16. Similarly, we are finding out the value of y square, that is 7 square 49, 2 square 4, 1 is 1, 1 is 1, and 2 is 4, and still up to last, that is 6 square is 36. Now we are finding out xy, where we are going to multiply the data of x and y. Okay, so 2 7s are 14, 6 2s are 12. Like that you are going to find out still up to last one, that is 6 4s are 24. For all these values, we are going to find out the sum. That means summation. This is nothing but summation x, this is summation y, this is summation x square, this is summation y square, and this is summation xy. For the information, I am going to write all the values whatever you have got in the previous table. Summation x, summation y, summation x square, summation y square, and summation xy, where n is nothing but the number of observations. N is 8. Initially, we are finding out x bar. X bar is summation x by n. Summation x is 931 by 8 is number of observations. You got 3.8750 as your x bar. And y bar is summation y by n. 24 by 8, that is of 3. Here y bar is equals to 3. Now r is equals to covariance of x comma y by sigma x into sigma y. Here it is of, now we are going to find out covariance of x comma y. Covariance of x comma y formula is 1 by n into summation xy minus x bar y bar. Already you know summation xy, x bar y bar, just we are going to substitute over there. You will be getting covariance of x comma y as minus 1.2500. Now we are going to substitute the value of covariance of x comma y and a sigma x and sigma y to find out the value of small r. Okay, what is the formula for sigma x? Sigma x is nothing but under root summation x square by n minus summation x by n whole square. Instead of writing summation x by n, we can write x bar whole square. Okay. By doing this, we got the value of sigma x as 2.0272 and sigma y as formula under root summation y square by n minus summation y by n whole square. Instead of writing summation y by n, we can write y bar whole square, where y bar is equals to 3. We got the value of sigma y as 2.2361 and sigma x as 2.0272. And you already know the value of covariance of x comma y. Just we are substituting all these three values in the value of small r to get the value of r, that is Karl-Pearson's correlation coefficient. R is equals to minus 1.2500 by 2.0272 into 2.2361. You got R is equals to minus 0.2758. As the value of R is always lying between minus 1 to plus 1, we got the value of minus 0.2758. Now we are going to find out the regression coefficients, that is Byx and Bxy. As Byx formula is R into sigma y by sigma x and Bxy is equals to R into sigma x by sigma y. We got the values of regression coefficients as Byx is equals to 0.3042 and Bxy is equals to 0.2500. Now the regression line of y on x you have to find out, and similarly we have to find out the regression line of x on y. This is regression line of y on x. Y minus y bar is equals to Byx into x minus x bar, where y bar is equals to 3 and Byx is 0.3042 and x bar is equals to 3.8750. By simplifying this, you got the regression line of y on x as y minus 0.3042x is equals to 1.8212. This is the regression line of y on x. Now the regression line of x on y. See, x bar that is 3.8750 and y bar that is of 3. Just we are substituting those two and we are substituting bxy as 0.2500. By simplifying, you got that x minus 0.2500 y is equals to 3.1250. This is the regression line of x on y. Now, in the question they ask you to find out the coefficient of correlation. The formula for R is equals to plus or minus square root of Byx into Bxy. Plus or minus square root of the regression coefficients should be multiplied. By substituting both those two, you got the value of small r as plus or minus 0.2758. Okay, which is equal to the value of small r. With that, the regression problem is completed. Thank you.